Welcome to qnawire.
In this problem, we have a wire where this distance is 30 meters, but the wire sags by 50 centimeters. And this is all at minus 15 degrees Celsius. Now, which means this is 15 meters and this is 15 meters. Now, let's think of this as a circle. And let's say this is theta. Obviously, this is also theta. Let's call this L. Now, once the temperature changes to 35 degrees Celsius, we know that this length L, let's say the initial length was L naught, becomes L naught times 1 plus alpha delta T. So first we need to find this length L naught, and then we can think about the expansion. Now, let's say this radius is R. Let's call this sag S naught. The initial sag is S naught, and this must be R minus 50 centimeters. R minus 50 being this length. So now, using the right angle triangle, we can see that R squared is equal to R minus 50 squared plus the 15 meters, which forms the other side of the triangle, 15 squared. Now this gives us R is equal to 15 squared plus 50 squared divided by 2 times 50, which turns out to be 225.25 meters. Hence, we found out this radius, and we can find now find theta. We know that radius times theta is equal to the arc length. So let's find theta first. We know that theta is sine inverse of 15 by r. Now that we've found r, this should be simple. By plugging this into a calculator, we can see that this is 6.64664 times 10 power minus 2 radians. Now L naught is simply R naught theta naught. Let's make them all knots, which gives us 225.25 times 6.664 times 10 power minus 2, which turns out to be 15.01 meters. Now, once the temperature goes to 35 degrees Celsius, the delta T is equal to, obviously, 35 degrees minus 15 degrees, which is 20 degrees Celsius. I'm sorry, the initial temperature was minus 15 degrees Celsius. So that's minus of minus 15, which is plus 50 degrees Celsius. Now, we know that the new length L is L naught times 1 plus alpha delta T, which is 15.011 times 1 plus, we know that alpha in this case is 17 times 10 power minus 6. We can simply look it up in a table, times 50, which is 15.024 meters. It's a very small difference. So now we need to find the sag. So for that, let's find sine theta. We know that sine theta is 15 by r, where r is the new radius, which means theta is equal to sine inverse of 15 by r, but let's leave it here. We know that sine theta is equal to 15 by r. Now, we also know that theta is equal to L by r. Now that we've just found L, which is 15.024 by r, we also saw that sine theta is equal to 15 by r. So we have two variables, theta and r, and two equations, but it's not an easy equation to solve without approximations. So because our theta is very small, we can make this approximation. Sine theta is equal to theta minus theta cubed by 3 factorial. If you remember the expansion of sine theta, there are a bunch of terms after this, which we are going to ignore. Now, let's divide this equation by this equation. Now, that gives us theta minus theta cube by 3 factorial divided by theta is equal to 15 by r divided by 15.024 by r, which gives us 1 minus theta square by 6 is equal to 15 divided by 15.024. By juggling it a bit, we see that theta square by 6 is equal to 0.024 by 15.024. And from this, we can see that find that theta is equal to 0.0979. Now, this might seem like a very tricky thing to do, and there is no easy way to do this. You simply have to solve enough problems to realize that this is the right way to do something. Now, we know that radius is simply 15.024 by theta. By substituting our values, we get our new radius is 153.46 meters. Now that we found our radius and theta, we need to find the new sag. If you remember our old formula, we know that 15 squared plus the radius minus sag squared is equal to r squared, which gives us 15 squared plus, minus 2rs plus s squared is equal to 0. We could use the quadratic formula, but because s is very small compared to r, we'll simply ignore this term, giving us s is equal to 15 squared by 2r, which turns out to be 73.3 centimeters. Now, of course, you could use the quadratic formula here to find s, and that would be fine too. But it wouldn't make much difference. So yeah, this is the new sag. Voila.